The masses of neutron and proton are 1.0087 atomic mass unit and 1.0073 atomic mass unit respectively. If the neutrons and protons combine to form a helium nucleus of mass 4.0015 atomic mass unit, the binding energy of the helium nucleus will be given 1 atomic mass unit is equal to 931 mega electron volt. So, we know binding energy is mass defect into velocity of photon or velocity of light square. This is in terms of joules if you want to get the answer, or else binding energy can also be written as we all know mass defect delta m into 931 931 because mass defect is in terms of atomic mass unit into 931 mega electron volt it will be. Okay. Now, all the atomic masses of the particles neutron and proton are given in terms of atomic mass units, right? So, what we have to do? They are given in terms of atomic mass units. So, now have to calculate the mass defect. Mass defect is they are forming a helium nucleus, no? Helium nucleus. So, for helium Z is 2 and A minus Z, that is, see if you take the picture of helium, it is 2He4, that is X, this is A, this is Z. So, this is atomic number and this is mass number. So, A minus Z is also 2, that is number of neutrons. So, now delta m is Z, number of protons into mass of the proton plus A minus Z, that is number of neutrons into mass of the neutron. This is a theoretical mass of the nucleus minus mass of the nucleus observed or measured mass of the nucleus. This is a theoretical value of the nucleus. So, that difference in the theoretically expected mass and observed mass is called mass defect, which will be converted into energy in order to hold on to the neutrons and protons inside the nucleus. This energy is the energy utilized for the stability of the nucleus. So, coming back to that, now since both are 2, it is 2 into mass of the proton is 1.0073 plus this is 4 minus 2 into 1.0087 minus 4.0015. This is mass defect delta m. Calculating this delta m, now binding energy is delta m into 931 mega electron volt. So, that if we calculate, that we will get it as 2 is common here, 2 into 1.0073 plus 1.0087 minus 4.0015. So, into these many units. So, calculating this, we get 28.4 mega electron volt. So, option A is the correct answer.